have close to 60 people online right now. Thank you so much for joining us. This is Lisa Clark. I'm the director of the Department of Environment, Great Lakes and Energy. We'll get started here in just a second. I think I'm going to let another minute pass to make sure that we've got as many of our task force members as possible. And then we'll start by going around and identifying our task force members, and then we'll jump into the agenda. Get started here in just a second. All right, it is 12:31, so why don't we go ahead and get started. So again, thanks for joining this next meeting of the UP Energy Task Force. This is Lisa Clark. I'm director of the Michigan Department of Environment, Great Lakes and Energy. Many of you are familiar with our processes, but just to remind folks, you can find lots of material on michigan.gov/UP Energy Task Force, including the agenda here for today, as well as task force members and our previous work. Including meeting recordings of our previous meetings, as well as presentations, and you can see public comment that we received. So our last meeting on May 12th, we had more than 120 attendees. So we thank everybody for participating. I think it makes a more robust conversation when we have lots of opportunity here from public. So before we get going into the agenda, I'm just going to check with our task force members to see who we've got on the line. I looked and found a lot of names, but I just want to make sure that we've noted everybody that we have. So I'm here. Let's see. Senator Mike Prusi. It's so hard for me to not call you Senator. Our UP Energy Task Force Vice Chairperson. Are you with us, Mike?
I am indeed.
Great. Tanya Pozlowski, serving as our secretary.
I'm on. Good afternoon, everyone.
Hey, Tanya. The next on my list in alphabetical is Chris Bowman, but I think Kimber said that Chris was not going to be able to join us today. Okay. Dave Camps. Dave, are you with us?
Hello, everybody. Yes,
hey,
I am here.
Dave. Great. Glad to have you. Okay. Mike Furmansky.
Hello, I'm here.
Hey, Mike. Tom Harrell. All right. Jen Hill.
I'm here.
Hi, Jen. Douglas Jester.
Hi.
Good afternoon.
Hi, Douglas. Aaron Johnson.
Hi, I'm here.
Hey, Aaron. Jim Kachiver.
Good afternoon, I'm here.
There's Jim. Great. Michael Larson.
Yep, here.
Hi, Michael. And our fourth Mike Nystrom. Last but not least.
Good afternoon.
Hi, Mike. Tony Ratasky. Tony, you were my center square if we were doing Brady Bunch.
Oh, so who would I be?
You buy.
I hope it's not Jan.
You're not Jan. I think that makes you the maid, right? Isn't that
Alice.
I think that's right. Alice?
Yeah.
Alice, thank you, Alice. Okay.
Ratasky, reporting in.
General Paul Rogers.
Good afternoon, I'm on.
Hi, General Rogers. Nice to hear your voice.
It's good to be back and active here. Sorry for my
busy guy. You're fine. You're a busy guy. We're thrilled to have you. Thank you. Commissioner Scripps.
I now go by Mike.
You go by Mike?
Yes, I'm the fifth Mike, yes.
Welcome.
Roman, Roman, are you with us? Oh, I didn't hear Roman. All right. Kimber, did you hear from Roman at all? No? Okay. He might be joining later. Chris Schwartz. Chris, are you with us? No, don't have Chris. And last but not least on my alphabetical list, Tanya Sweener. No, sounds like we don't have Tanya either. Okay, we will follow up. Great. Well, thanks everybody. Thanks to our task force members. I keep losing track of which meeting we're at, but we're at a lot. So I continue to be grateful for your commitment to this important conversation, and it really makes all the difference to have an engaged and active task force present. So really appreciate that. So we are going to start by doing some housekeeping. So first, I'd like to have everybody take a look at the draft agenda for today. You received it on Tuesday, June 2nd. It's pretty high level. We're going to have a presentation on transmission systems from Ken Kopp at ATC. And then one of our favorite guests, Kathy Cole, will be back again to talk a bit about MISO, which will be excellent. We will, oh, Tanya's here. She's having issues. She's on mute. Okay, thanks, Tanya. Glad you're here. We will keep going, assuming that you can hear us, and maybe we can get your technical issue solved. So back to the agenda. We're going to have a presentation by ATC and by Kathy Cole from the Michigan Public Service Commission. And then we have time slotted for a task force work session where I'm hoping we can talk a bit about what we heard in addition to questions you all might raise after those presentations, and then talk a bit about where we're going and what types of presentations we want to make sure we hear. Then we have half an hour slotted for public comment. So hopefully some of those folks that have joined us either through video or on the line will be interested in sharing public comment with us. And so just as a precursor to that, I want to remind folks, we are always receiving email public comments. And we also, you can do that on our website, michigan.gov/UP Energy Task Force. And that is shared with all the task force members at regular intervals. Kimber keeps everybody really well informed. When we take comment during our meetings, we do keep it to 3 minutes of comments, please, so that we can work our way through everybody that we've got. And then we will adjourn at 3 o'clock or around thereof. If you're interested in giving public comment when we get to that point, and even before that point, you can certainly send us an email. Kimber had that slide up on the screen. So that we can get everybody in line, or raise your hand or mention something in the chat, and we will make sure we get to you. Okay, but back to the agenda. So I'm wondering if there is a motion to approve the agenda for today.
Motion to approve, Madam Chair.
Thank you. Do I have a second?
Second.
Second. Any discussion on today's agenda? All right, with that, all in favor?
Aye.
Any opposed? Okay, great. Agenda's adopted. Next, from a housekeeping perspective, we're going to step to our meeting minutes. So you have meeting minutes in front of you from April 13th. Hopefully you've had a chance to take a look at them. So let's go ahead and move them, and then we'll have discussion. So do I have a motion to approve the April 13th meeting minutes?
So moved.
Thank
This
you.
is Douglas.
Thanks, Douglas. Second.
Second, Mike Fransky.
Thank you, Mike. Any discussion on the April 13th meeting minutes? Great. So if I can have everyone in favor?
Aye.
Aye.
Any opposition? Great. So those meeting minutes will be posted on our website for those of you who are following along at home. Next, another set of meeting minutes, the May 12th meeting minutes. And I should have mentioned that everyone should have received these on June 4th. So hopefully you've had a chance to take a look at them. So let's go ahead and move the May 12th meeting minutes, and then we'll have discussion. So do I have a motion to approve?
This is Douglas. I move approval.
Thank you. Any second?
Support.
Thank you, Tony. Any discussion on the May 12th meeting minutes? All right, another huge thank you to Kathy Cole for doing such a great job at that meeting. We get to hear from her again. She's going to be a frequent guest of ours. So with that, all in favor, please say aye.
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 Any opposition? Great, thank you. So again, for those of you that are following along, both the April 13th and the May 12th meeting minutes will be posted then on our website if those were things you were looking for. So just wanted to mention going forward, I think we've all been sort of anxious to get back to an opportunity to do an in-person meeting. I know that I like seeing your faces on video, but it sure would be nice to get together as well. Our fingers are crossed that that might be possible July 15th. We are scheduled to be at the Gogebic Community College in Ironwood. At this point, I would say it's tentative. I guess I'm interested in what you all are interested in doing to the extent that you feel comfortable traveling and being together. And I would say too that if we were to decide to do something in person, there would always be the opportunity for those who were able to travel or didn't feel comfortable traveling to participate virtually as well. So, you know, I'm interested in your perspectives. Obviously, it'll depend upon where we're at from a order perspective, but it looks like, you know, that's a possibility in the Upper Peninsula at that point. So, you know, feel free to let me know what you think. You guys are never bashful about your opinion. So for now, I'd like to say we hold it as a meeting date, and then we'll just determine whether we're in person once we get closer. Any initial thoughts on that?
Well, based on everyone's videos, Madam Chair, I would say that we should shoot for it up there, especially if the barber shops are open, because all these guys on these pictures need haircuts. So we should all head up there and do it.
Excellent plan, Mike. Excellent plan. All right. Well, I know I would love a trip to Ironwood, so I haven't really gone very far in many weeks, but we'll see if we're all feeling safe about it by then. Okay. With that, all right, I already mentioned we've got public comment scheduled for 2:30 today, so I'm just going to re-articulate. If you are on the line and you want, I saw a couple of hands go up and some comments in the chat. Thanks for doing that. We'll put you in line. You may also send an email to eagle-upenergy@michigan.gov with your name, and then in the subject, you might want to say that you request a comment today at the June 9th meeting. That'll help us make sure we get everybody. And so Kimber will help me get everybody in queue. So thank you, Kimber. All right. Let me mention too that we did receive one request to give public comment already. So we will certainly have that person on the list. So with that, we're already ahead of schedule. Look at what a great job we did. It is 12:42, and I would like to now turn it over to Ken Kopp from ATC, the American Transmission Company. Before I hand it over to Ken, I would like to say that it probably makes sense to hold our questions till the end with Ken. And then after he finishes, we have a chance to ask some questions. We'll then turn it over to Kathy Cole. So with that, let's see if we can get the technology working. Ken, I can see you. I see your slides, and if you just want to unmute so we can all hear you.
There we go.
You sound great.
Very good.
I cede the floor.
Okay, and thanks very much to Kimber and the rest of the staff for helping us work through the challenges of using Teams. So we use soft product, but not Teams, so it was a little bit of a learning curve. This is a follow-up to Kathy Cole's Energy 101. We're going to focus on transmission, maybe transmission in general, but also more specifically on Upper Peninsula transmission. The transmission system provides an integrating function as the service that MISO actually sells to its customers is called Network Integration Transmission Service, NITS, N-I-T-S for short. So what we're integrating is resources, what we used to call generation, but now resources includes demand response and a variety of other things, and load, retail customers. The customers that ATC has are municipal utilities, cooperative utilities, and investor-owned utilities. So we have a relatively small list of customers that we serve, and those customers in turn serve about 5 million people across Wisconsin and the Upper Peninsula. Let me see if I can go to the next slide here. Doesn't seem to want to move for me. There we go. So we've got the question here, what is transmission? And from ATC's perspective, anything over 50,000 volts, 50 kV is transmission. And in the Upper Peninsula, that would embrace systems that are at 69,000 volts, 138,000 volts, and 345,000 volts in the ATC footprint. ATC is basically responsible for all of the Upper Peninsula except except for the very far western portions of Gogebic and Ontonagon counties. That is served by Northern States Power Wisconsin, doing business as Excel. And they, to my recollection, operate an 88 kV set of facilities over in that part of the UP. So the integration process puts us in a spot where our customers are both the generators, the resource providers, and the load serving entities. So when we build a model, we wind up with the generation and the load incorporated, even though that's not ours, not what we own. So we'll talk about how the pieces and parts are placed in the model, and I can talk with confidence. Oops. I don't want to go to the YouTube. that is part of the slide set here, but I want to move on to the next slide here. In the YouTube there, it talks about the transmission system with an analogy to a transportation infrastructure, and we'll talk a little bit more about that. And we'll use a map that's outside of the presentation itself. Have to back out of the PowerPoint and project a PDF of a map, which will allow us to maybe scan the Upper Peninsula and look at what some of the specific facilities are. So ATC began in 2001. We're headquartered in Pewaukee, Wisconsin, which is just west of Milwaukee. Nearly 600 employees. And note that the Kingsford office is in the Upper Peninsula. We have 21 employees there, and that would include our system planning staff, project management, asset management, and maintenance management folks that are up in the Upper Peninsula, along with some additional support that comes out of our De Pere office, which is a suburb of Green Bay. So our environmental and real estate folks come out of the De Pere office. I think that the analogy to the Highly system is something that when we talk about transmission, it's sometimes a little bit hard to absorb exactly what's going on with the wires, what's the capability of the wires, how far can the energy travel on those wires. So we'll go back and revisit that a little bit. ATC operates in 4 states. We're going to be talking about the portion in Michigan today. About 9,900 miles of lines and about 568 substations. When we get to slide 7, I'm going to give you the specifics about what portion of that is in the Upper Peninsula. So keep that in mind as we're looking at slide 4 here. We do operate 2 control centers that are redundant. So we have one in the Madison, Wisconsin area and one at our Pewaukee headquarters. And we're scanning the system basically about every 5 seconds. We receive a complete set of new information from the system telling us what the voltage is, what the flow on the lines are, and whether or not there's any specific system elements that need additional attention. Those come to the attention of the system operators through an alarm, which calls to their attention that they need to focus on a specific element. When we say all we do is transmission, as I talked about, it's an integrating piece of the infrastructure. So when we say all we do is transmission, what we're doing is making sure that all of the load is being served at the wholesale level, and also that all the resources have access to provide reliability. But we'll also talk a little bit about the MISO market. I don't want to step on too much of what Kathy Cole's going to talk about a little bit later, but hopefully that will complement what Kathy's going to talk about. The third bullet here, regulated by FERC, Federal Energy Regulatory Commission. So our rates and tariffs are set by FERC, and it's a little bit different than what Kathy described. She talked about the formation of Michigan-only utilities, UMERC, and the balancing authority, Upper Peninsula, Upper Michigan, MIUP, as a balancing authority. For rates and tariffs, ATC operates only one rate zone. So Michigan customers, Illinois customers, Minnesota customers, and Wisconsin customers all pay the same wholesale transmission service rates. And the costs of building the transmission system are then put into one rate base and then allocated back to individual customers in accordance with the FERC tariff. Takes into account the demand and the energy attributes in allocating that back to the end use customers. What does ATC do compared to what MISO does, the Mid-Continent Independent System Operator? We are the transmission owner, the transmission operator, and the transmission planner. So we take the first crack at doing all of the operations details and all of the planning details for the entire ATC footprint. MISO's role is what is referred to as the reliability coordinator. They're looking over our shoulder from a system operations point of view and making sure that the operating steps that we take are consistent with the entire 14-state footprint that MISO covers. On the planning side, they are the planning coordinator, similar role. They're making sure that ATC's system plans can be integrated into the plans of our neighbors without, quote, doing any harm. So many times MISO will refer to some of their analysis as do no harm analysis, making sure that ATC's plans are consistent with the broader plans of the region. They also hold the tariff, so all of the regulatory work that goes through the tariff actually goes through MISO, and then ATC participates in that. And then they operate the market, which is probably when folks think about MISO, the market is the first thing that comes to mind. A lot of money transacts through that market. It's basically takes some classic principles of dispatching your energy resources in an economic dispatch order, the lowest cost to the highest cost, but it puts it through a model that is computerized and allows day ahead, every day, all of the generation offers their generation into the market. All of the load bids their load into the market, and they're matched together, and a dispatch order and commitment of resources is created. And then in the actual real time, a second market, the real time market, makes sure that any deviations from the day ahead plan are taken care of so that the lights stay on for everybody. So ATC began with $550 million worth of assets. Those assets came from the incumbent utilities. So in the Upper Peninsula, Wisconsin Electric Power Company, Upper Peninsula Power Company, Wisconsin Public Service, and Edison Sioux, along with the Cloverland Cooperative, were early divestors of their 69,000 volt, 138,000 volt, and 345,000 volt assets to the American Transmission Company so that we could operate them more holistically and try to break down the boundaries between the incumbent utilities, the retail utilities, and try to make the transmission system more efficient, more well-planned, more seamlessly operated. Later, City of Escanaba and Mike Fermansky, make sure I get this right, divested some of their 69 kV assets to us a few years after our startup in 2001. We take great pride in our use of data and metrics, and the electric industry is just replete with, if we're gathering every 3 seconds the status of the system, we have lots and lots of data at our disposal to wade through, making sure that we're targeting our plans and our asset maintenance, asset management to make sure that we are a top performer in reliability, ranking in the second quartile for our 69 kV and 100 kV class circuits, and best in class, upper decile for our 345 and circuits. In addition to that, we've got a handful of other metrics that are helpful. We track SAIDI and SAFI, system average frequency of interruptions, system average duration of interruptions. And one of the things we've been able to do, especially in the upper peninsula, where distance matters a lot, put in some motor operated disconnect switches that are remotely controlled from our control centers, and take that duration. We identified that duration of outages was a key issue, and by strategically locating some of those motor operated remote controlled switches, we were able to take that duration metric down for customers that have been impacted by about 85%. So statistical analysis of and use of metrics to make sure that we're doing the right things to make sure that the system is operated well and planned very well. The size of our footprint in terms of energy and megawatts, about 12,500 megawatts. Again, on slide 7, we'll talk about how much of that is in the upper peninsula, and 100% approval rate of our projects from state commissions. A couple of slides ago talked about, mostly being regulated by FERC. We're a federally regulated entity, but when it comes to routing and siting and environmental issues, those things are very, very important at the state level. So we have achieved 100% approval of our project proposals from the state commissions. Many more of those are in Wisconsin. There's a difference between the way certificates are required. In Michigan, we've had one certificate of need in the Escanaba area, Delta County, which helped us with some routing and siting issues. The rest of our approvals are in the state of Wisconsin, and we're very proud of the fact that we've been very diligent in the way we plan our projects and have achieved 100% project approval. So the UP details, which I think is what you're all much more interested in. ATC has invested $810 million in the UP since 2001. That amounts to about 20% of the capital that we've expended. And in addition to the $800 million that has been expended in the past, our 10-year assessment looking forward into the next 10 years would predict another $300 million of investment looking forward. Our transmission lines, 345, 77 miles of that, 77 miles connecting Iron Mountain to the city of Marquette, or the north side of the city of Marquette, where the Presque Isle power plant, now retired, but the switch yard is still active as a transmission substation. 950 miles, 15 miles of 138,000 volt infrastructure. And the majority is at the 69 kV level, 69,000 volt, over 1,000 miles. In terms of just trying to give you a flavor for what each of those system voltages does, we think of the 345 as an interstate highway. It's the most efficient way to push energy long distances. And when we're talking about long distances, we would say a 345 line, 150 to 250 miles between substations is not out of the operating capability of that. So moving energy state to state, long distances. Similar to an interstate highway, though, only very selected spots where you can get on and off. So the on-ramps and off-ramps are very, very limited on our 345 system. The 138, I would say, is more like a state and federal two-lane highways. So think, US Highway 2, US Highway 41. You can go a lot more places, lots more crossroads where you can get on and off. But it's not as efficient. You are going to be suffering more loss of the energy as you push it through that 138 kV system. And the legacy of the Upper Peninsula, there wasn't a lot of 138. The 138 was really focused in Marquette County between the Presque Isle plant and the mines, Empire and Tilden mines in the western portion of Marquette County. And that leaves us with the 69 kV system. Think county and township roads, 45, 50 mile an hour speed limits. It gets you to the very detailed places where you want to go, but you really have to be careful with how long those lines are. Probably the optimal length of a 69 kV circuit would be 35, 40 miles. And my recollection from the days when I worked up in the UP for Wisconsin Electric before joining American Transmission Company, I was always 50 miles from where I wanted to be next. So the 69 is very effective in a local delivery capacity. But when we take a look at what has happened, especially with the implementation of the MISO market, the market is relentlessly efficient in finding the economic dispatch of energy, and it tends to move energy longer distances than, say, 20 or 30 or 40 or 50 years ago. So the 69 will point out a couple of places where it is a little bit overwhelmed by the amount of system energy that now moves over those longer distances. Substations, a total of 83 out of the total group. Many of them are joint with our customers. 25 are transmission-only substations. And then I reached back, and actually this is a Michigan Public Service Commission case back from 2017, but looking forward to our summer peak of 2022 and projecting that it was a case talking about summer reliability plans. And we were able to capture the load that is in those models for 2022. 780 megawatts of load would constitute most of the Upper Peninsula. The things that are missing there would be the Excel portion, far western Gogebic and Ontonagon counties, and the city of Marquette. City of Marquette, Marquette Board of Light and Power is a transmission neighbor of ours. They have their own generation, they have their own load serving, and they only participate in the MISO market at this time on what's called a point-to-point basis. So they do, from time to time, import or export power, but they're not a network integration customer. So they're modeled in that 2022 case as fully self-sufficient, which is not a bad way to characterize them. That's about where they sit today. The UP generation that was online in the model is 370 megawatts. So the dispatch of and that already anticipated the retirement of Presque Isle and the inclusion of the reciprocating internal combustion engine, or RICE units, being online that are owned by UMERC. The import capability, you can see the maximum would be 620 megawatts. So for that summer case, 370 of the 780 megawatts of consumption would be from inside the UP, and the remainder would be coming from elements that are outside of the UP, and that there's a sufficient margin to be comfortable that the 780 megawatts of load would be completely served and reliable. So if you're interested in that particular case, I put the case number here. It's a nice short, it's only about 4 pages long, but it kind of concisely talks about the locations where energy can enter or exit the UP and the comparison of that with the resources that are local in the UP. And I'm going to have to patiently push buttons till I can get the slide to go. This is a map right in the PDF here. We'll be kind of taking a look at the system elements that make up the system. Talk just briefly about, you can see this north to south corridor that heads down toward Green Bay. Extremely important. That's where a lot of the legacy infrastructure that allowed energy to move into the Upper Peninsula has come from. We'll talk a little bit about a change over here in the Western UP, where originally the two systems, the Wisconsin system and the Upper Peninsula system, were not connected, even though they were very close to one another. That is one of the places where we've made some improvements in the first decade of ATC's existence. And you can see the numbers here are projects. When this was published, comes from our 10-year assessment. It's on our website. It's publicly available. And these are the 7 major projects that are currently ongoing and were important at the end of that particular assessment. A couple over in the Eastern UP, a couple in the greater Marquette area, and then a couple over in the Houghton and Keweenaw area. So what were those projects? The first one we called Northern Umbrella Project. This was something that we knew we had to do fairly early. That corridor north from Green Bay into Iron Mountain, very important, but originally sized taking into account the Wisconsin electric service load in Iron Mountain. That was really the focus of that line and infrastructure. At a later date, it became more important to be able to move energy a little further and at a larger level. So rebuilding that legacy line, which dated back to the 1910s, with more capable infrastructure, was one of the first things that we did. And we'll talk a little bit more when we get to the map looking at that. Eagle River and Conover are in Wisconsin, but Conover is just south of Watersmeet. That was the place where we were able to connect the 115,000 volt system in Wisconsin with the 138,000 volts new line that we built from Conover to Iron River to Iron Mountain, so that not all of our eggs were in one basket in that corridor reaching south toward Green Bay. Now we had a western point of injection or import and export from the Upper Peninsula, and 138 kV infrastructure complementing the 69 kV infrastructure. Legacy, that entire space from Iron Mountain to Iron River to Watersmeet was only 69,000, pretty long-legged. Worked fine because Wisconsin Electric was only serving small amounts of load, and it was a radial circuit. It wound up being a radial circuit that went north from Watersmeet up to Mass. Needing system capability, you needed the higher capability of the 138 kV line. And then in the Eastern UP, connecting Manistique to Engadine with a double circuit 138 kV line. Again, that was a piece of infrastructure that was only at 69,000 volts. And being able to move energy from that central UP corridor, which is the main import location, further to the Eastern UP was very important. So that was a piece of what we did in the first 10 years. Stuff that went in service 2005, 6, and 8, approximately. What we found was there was more to do. We had created a nice southern corridor all the way from Watersmeet, or the western area, to Iron Mountain, and then Iron Mountain to the area north of Escanaba, but not through Escanaba, and over toward Manistee and then ultimately St. Ignace. We engaged with our customers in a collaborative process to come up with what were the load serving needs of our that our customers saw, and came up with a handful of kind of second decade projects. A number of them centered around Delta County. Chandler is a 138 kV station at the northern edge, not into the city of Escanaba. We brought circuits, the 138 and 69 circuits from Chandler down to Escanaba, and then later complemented that with a circuit that came up from the southwest, from Holmes, which is over on the Nanami River, and brought that 138 kV infrastructure into Delta County as well. Created another off-ramp from the 345 system to the 138 system in Arnold. Arnold is actually in Marquette County, but it gave us an important extra point of injection and capability, serving southern Marquette County, but also very important to the Delta County and Escanaba areas. And then what we had found with the infrastructure connecting Manistee to Engadine, we were overloading the capability of the system, especially in the eastern UP, which is got a lot of 69,000 volt infrastructure. We needed a way to control that flow. And the answer to that question was to build a HVDC, high voltage direct current flow control project that gives us a place where we can actually dial in the amount of energy that is transacted between the Upper Peninsula and the Lower Peninsula, and it allows us to make sure that we don't overwhelm some of those legacy circuits while we're in the process of upgrading and rebuilding them. And then the final piece is that with the announcement that Presque Isle Power Plant was going to be retired, we needed to go back to the south end of that corridor, actually go to our North Appleton substation, southwest of Green Bay, extend a 345 and 138 kV line. Sort of think of it as the roots of the tree that's coming up, and then the stem of the tree goes from north of Green Bay up to Iron Mountain, and then the branches of the tree spread out in the Upper Peninsula. It gave us an additional capability around the legacy infrastructure in the Green Bay area. A static VAR compensator, which is a electronically controlled capacitive and inductive device. With the loss of the spinning machinery at Presque Isle, we needed the ability to control the voltage in a dynamic way. And then ultimately, the Huron substation and Silver River substation are the substations that host Huron, hosts the Custer rice units, and Silver River hosts the NIM rice units. Let me just duck out here for a second and go to the map and maybe talk a little bit more about where those projects are and give you a little bit more of a flavor for what they entailed. Let's see here. There we go. It's not going to let me do this.
So if you try unsharing your screen right now and then reshare it with the drop down arrow, and then you can select the map that you want to show.
Exactly. So I'm going to reshare and then grab this particular map. Can you see the map at this point?
Yes.
Yes.
Okay. So if I scroll a little bit to the west here and then down, you can see this stem that comes up from the Green Bay area. The red line is the 345 line. That's a very, very capable line. But when there's only one 345 line by itself, it by itself has a capability of about 900 megawatts. But because for loss of that line, and I'm the electricity traveling at the speed of light and the laws of physics being what they are, I always have to operate assuming that the next bad thing happens. We call that N-1 operation. So for the loss of the 345 line, I'm relying on my 138 kV infrastructure, here this gray line. And then when I get up to this area, the Holmes to Old Mead Road project provided an additional, a third 138 kV path, which was complemented by this 138 kV that goes all the way down to Menominee. So ultimately, this circuit, which started out probably having a capability of around 200 megawatts total, now has a capability of about 500 megawatts total in terms of energy that can be pushed up to the Iron Mountain area. The other piece that I wanted to point out here is in those first set of projects connecting Eagle River here on the west to Conover, and then building this 138 kV corridor to complement the green lines. The gray lines are 138,000 volts. The green lines are 69,000 volts. Now I've got, in addition to the infrastructure that's coming into southern Dickinson County, I've got infrastructure that's moving across Iron County and Dickinson and supporting that. The new transformer on the 345 here at Arnold is very, very important because otherwise the only off ramps I can get energy off my 345 down here in Quinnipiac, where it's just east of Iron Mountain, and up here at Dead River, which is on the Presque Isle property. With Presque Isle no longer being a generation resource, was helpful to have another place where I could push energy up toward the southern portion of Marquette, over toward Munising, and also down to this corridor, this long corridor that goes all the way over to the eastern UP. When I get to the eastern UP, the thing that should catch your eye, lots of green, and not necessarily complete continuity. So you can see the original boundary of Upper Peninsula Power Company here, and the original boundary of Edison Sioux Power Company, Edison Sioux Electric over here. Now Edison Sioux now is incorporated into the Cloverland footprint. So the ability to manage the amount of flow here really protects the capability of this infrastructure, this 69 kV infrastructure, that would be in deep trouble if I lost this Hiawatha or Engadine area to St. Ignace area, 138 kV. Again, using that one N-1, or when the next bad thing happens. These circuits are too long and at a too low a voltage to successfully move the amount of power that would want to flow into the lower peninsula based on some of the market dynamics. You see that this corridor is one of them that is being upgraded. It's not being upgraded to 138 at this point, though. It is being upgraded for select poles and a slightly larger conductor in some locations. So you wind up with sort of the story being the east to west infrastructure was the first thing that was improved. You still weren't able to totally bring energy all the way up to the Lake Superior shoreline. That space was really kind of reserved for the Presque Isle units, which are up on, or were once on the shores of Lake Superior. The other thing that is important to us is that with the MIM and Custer units, the ones, the Baraga County area over here, And over in this cluster of infrastructure just outside of Marquette, you can see Huron is the substation name, and Custer is the name of the units right here. Those RICE units are pretty efficient. Natural gas is a great source, but they don't run 24 hours a day the way Presque Isle did. They cycle pretty much on a daily basis. Late evening, they come offline. Early morning, they come back online, responding to the energy price signals. There was sufficient in that second set, the second decade of infrastructure upgrades. We were able to make sure that we not only could control the voltage without a rotating machine online in the UP to help us, but also allow the generators and the customers in the UT to take advantage of the lower prices on the market when the local generation would not have been the economic dispatch of choice. Over here, just want to point out this 69,000 volt line that moves all the way up from Conover, Land O'Lakes, Waters Meet, Bruce Crossing, Mass. That was a perfectly wonderful piece of infrastructure when Wisconsin Electric fed those relatively small loads radially. It's 70 miles from Conover all the way to the Winona sub. And that infrastructure is only capable of moving about 20 megawatts, a pretty small number, in support of the Houghton area and further up the Keweenaw. So that's an example where system flows at the levels that we'd like to see them at are not supported by sort of the legacy infrastructure and the way it was built for the purpose and worked well for the purpose when it was built. The integration that we're trying to do today or that we need to do today doesn't always fit perfectly into that space. We can come back to this map maybe at the end if you've got some additional questions and details. I'm going to try and get myself back over to let's see. Obviously, I'm a novice at this. There we go. I need to click.
You look like a pro, Ken.
Trying. And so now I want to share and go back to my PowerPoint. So at this point, everything I've talked about so far is really reliability, what it takes to keep the lights on. Talk a little bit about the energy flows that are created by the market. And really, this is similar to a slide that Kathy showed you. The Minnesota hub here, I want to take a look at this Minnesota price, wholesale price of energy. And really, when you're looking at these LMPs, think of the price of fuel. That's really what they are. The locational marginal price of energy is very, very tightly related to the price of the fuel. This MISO number over here is called the reference price. If there was a perfect transmission system that could move the energy all the places that you wanted to in the MISO footprint, the price would be $27 a megawatt hour. The trapped energy west of the Mississippi, where you've got 7,000 megawatts of wind in Iowa, another 3,000 megawatts of wind in southern Minnesota, and hydro energy that comes down from Manitoba. Not all of that energy has pathways to get across the Mississippi, so you see a depressed price in Minnesota. The ATC price is pretty much the MISO reference price. And then Michigan, you've got another bottleneck here where not all of that low-priced energy can make it all the way to the lower peninsula. So the lower peninsula has a price $5 different than the Minnesota hub. When you look at the UP, there's two paths for that energy to take. It relentlessly tries to go from low-cost production to high-cost market. much of it, 98% of it, takes this pathway through northern Illinois and northern Indiana and into southern Michigan. About 2% of it takes the trip across the Upper Peninsula. And with the 69 kV facilities, they just are not capable of even that relatively small share moving that long distance over to the lower, from the lower peninsula into the, from the Upper Peninsula into the lower peninsula. And that's why the HVDC device sits where it does. So it's able to give us control over the amount of flow into the lower peninsula, but it disrupts the market. And we'll talk a little bit more about that. So the locational marginal price, marginal energy component, that's the price that everybody would pay if you had a perfect system. That's the $27 price, the reference node price, plus the marginal congestion component. That's the extra expense in terms of burning fuel that's not the next fuel you want to use in economic dispatch order. So this is a fuel cost. And then marginal loss component. For simplicity, in many cases, MISO will incorporate the losses, but not as accurately. And in the UP, with distance being what it is, that sometimes leads to a bit of a misleading signal. Essentially, the losses are a curved line. The simple math that you have to do if you're recalculating the system dispatch every 5 minutes, which is what MISO does in the real-time market, there's just not time to calculate where you're going on the curve. So they simplify it and they say, well, it's where it's at. Let's move it on a straight line, touching the curve. With distance mattering in the UP, when you look at that locational marginal price, you need to then dive into the next level of additional analysis and not use that simplifying loss assumption. When the market was formed, there are two narrow constrained areas: WUMS, the Wisconsin Upper Michigan System, and Northern WUMS. That would be the UP. Both of those were areas that the independent market monitor had identified as being underserved by the transmission system and therefore subject to the independent market monitor just takes extra steps in terms of how the generation offers itself into the market to make sure that those narrow constrained areas, that there's no abuse of the market or manipulation of the market. We have essentially, the fact that we can allow the MIM and QSTER units to actually take that market signal, get that rhythm of offline, late evening, back online, early morning, would be an indication that we've been successful in removing much of the constraint there. The market monitor has very strict rules though, and those narrow constraint designations still exist today, even though we feel like we mostly accomplished what we wanted to. When we look at reliability projects, we also look for the economic value. ATC has developed a customer benefit metric, which basically, you follow the dollars in the market. The load pays, the generators get paid. You need to take into account the financial transmission rights that have been granted to some of the legacy users of the transmission system. And then you have to recalculate and recalibrate the losses to come up with the this customer benefit metric, which pretty comprehensively looks at the economic value of the transmission projects that we build. And typically we find that the reliability projects have a 20 to 30% economic benefit. So think of it, you go shop at the store of your choice and you find what you want and it's on sale for 30% off. That would be the economic benefit. You're paying the full tariff price of the new infrastructure, but on the energy side, you're getting the benefit of the market delivering the economic dispatch of energy. When the market fails, you wind up with some things categorized as voltage and local reliability elements. That's a thing that we have worked really hard to try to capture across the UP. The simple thing to think about is that for simplicity, MISO models the system as a direct current system. It finds all the hot wires that need to be respected and makes sure that the dispatch doesn't burn those wires down. But they don't have time to run a more robust analysis that would capture all the voltage excursions that occur in the system. That falls back to us, and it's a place where MISO actually puts their thumb on the scale. They know where those voltage sensitive areas are. In addition to the market charges, there are VLR assessments, voltage and local reliability assessments, that are settled outside of the energy market. And so that's just another piece of what we try to track to make sure that we're building the right projects and addressing the issues that our customers see. What comes next? Capacity is extremely important. When Presque Isle was a big resource in the Upper Peninsula, a coal-fired resource, it not only produced energy, but on the hottest day of the year, when you did the statistical assessment, it had a 90 to 95% probability that it was going to be operating at its capacity on that hottest day, that most intense day of use. That's when capacity becomes important. The wind resources that have stepped in to provide energy, MISO credits them only at 15.6% for capacity credit. So the probability that you're going to have a very hot but very calm day is fairly high. Somewhere in the MISO footprint, 15% of the wind is going to be blowing and those resources producing energy, but it's not the same as the resources that are being retired. So as you think about that resource mix changing, you need to think about that capacity. Solar resources are in the models at 50%. Conversation with MISO just actually last week, Friday, they're saying they're moving that closer to 70% for summer modeling. And it makes sense. On a very hot summer day when energy use is very intense, solar resources should be available. In the UP, when we think about the winter peak, so the first week of January and the sun sets central time at 4:17 in the afternoon, the winter peak capacity credit for the solar resources will be less. It might be zero, depending on how you think about that peak hour of intense winter peak usage. So the transmission system winds up being very important in terms of modeling and understanding the import and export capability to complement the changing capacity attributes of the resources that are emerging as we transition from a carbon fueled to a low carbon fueled set of resources. The other thing that is important here, and we're just learning more about, the inverter connected resource control stability. So every time you have a solar panel or a wind farm, it doesn't produce energy synchronously with the 60 cycle energy that moves across the system. So you have to have, think of it as a battery charger running backwards. You're taking direct current and you're inverting it to follow the waveform that a rotating machine would create. But if those inverters become unstable, they disconnect those resources. So we're looking at the concept of a single event. So think of a lightning strike or something that causes an impulse to move through the transmission system that could disconnect lots and lots of these inverter connected wind and solar resources. And also looking at the fact that the inertia, rotating inertia and fault current of the system that we always thought was there and kind of took for granted is also changing. So the bottom line here is that the transmission planning process becomes more complex, more things to think about. Can't assume that the capacity just comes along with the energy. And some of those details just wanted to mention as we kind of come to the end of this. So our last slide here, John Garvin is the contact that kind of got us going on this presentation. Wanted to put John's contact information and my contact information at the end of the slide deck in case you've got more questions. And if there are questions, I think we've got a little bit of time. I'll toss it back to our chair and see what we want to do next here.
Great, thank you, Ken. First of all, appreciate the presentation. And if you're willing to take some questions from task force members, I think that would be great now. I'm going to steal the chair's prerogative and just ask the first one. So I appreciate what you laid out here. It's really illuminating. In particular, the map was super helpful to see where the projects are going in. The last slide, you talked a bit about the issues with inertia, capacity, et cetera. But I'm wondering from a geography perspective, if you could describe where the limitations are that you see across the Upper Peninsula from the ATC perspective, where would you like to see additional focus?
Great question. And as a planner, I think I have at least some initial thoughts here. Let me unshare this and go back to the map. You can see this corridor here, a pair of 138 kV lines that exit Perch Lake and North Lake. So right near the mines. That corridor is extraordinarily important to Houghton's reliability. So this corridor here, 69 kV line, as a matter of fact, we just presented that at the MISO MTEP, MISO Transmission Expansion Planning. That is a piece of the corridor that needs to be upgraded, just to make sure that the greater Houghton area. And I already pointed to this much too long line. Anything we can do in the western end to help complement sort of that central corridor. We get a lot of energy into Dickinson and Marquette counties. And now with the infrastructure that was recently built here, we've pretty well incorporated Escanaba into that as well. The Western UP keeps me awake, trying to figure out how can I do a better job with that. And the Eastern UP, which is, you think of the Keweenaw Peninsula as a peninsula, but Mackinac, Chippewa, Luce, Schoolcraft, those counties, and the ability to move that energy across this corridor and then get it further north towards Sault Ste. Marie. Those are things that, those are the places that I would point to. Maybe closing this gap following Highway 28 across might be a transportation corridor that could become a more completed electric transfer corridor. But those are the sorts of things that we're thinking about.
Great, thanks, Ken. Other questions from task force members for Ken?
I have a question.
Sounds
Yes.
good. Is that Jen?
Yeah, sorry. Yeah, this is Jen.
Thanks.
I'm having to call in on the phone, so it's a little awkward. My question is about what's happening across the straits. It's my understanding that the line that connected the two was cut in half in April or in spring 2018 by the anchor strike, and that I believe there is construction going on. If you could confirm that, and could a new line go through the proposed tunnel?
So two parts to that. Yes, all the transmission lines consist of 3 working conductors. We name them phases A, B, and C. There were 6 conductors under the straits. 3 of them were severed or damaged. We were able to put back together 3 working phases. And so we have one continuous path today. We're working to remove, the next step of construction will be to remove the 3 damaged cables. That'll be something that will happen July, late summer this year. And then the in-service date for the new circuits will be end of next summer, so end of 2022. The new cable will be embedded in the lake bed, so that it will be physically protected. Slightly different than the infrastructure that was installed in the early 70s and a little bit later, late 80s. So there will be protection there. Could it be in a tunnel? There are transmission lines that go through tunnels. It's really, really scary to share space with flammable fluids, petroleum liquids, things like that. And timeliness is of the essence in terms of restoring that. So being a part of a tunnel that isn't existing yet is one of the reasons that we're moving forward independently, basically because schedule is so important to restoring that reliability piece of infrastructure.
Great. Other
Thank you. That was
questions? Other questions from task force members for Ken? Do we have other questions from task force members for Ken?
Hi, Ken. This is Paul Rogers. When you talk about resiliency, can you comment a little bit on cyber protection and resiliency for your network?
I will talk a little bit about it, and I'm prohibited from telling you exactly how we do it, because of what the federal government refers to as CEII, Critical Infrastructure Information. So the cyber is a thing that we are very, very attuned to, because we operate a grid that's pretty far flung across the multiple states. We wind up needing to have a lot of communications infrastructure that brings that information back to our control centers. 2 things are causing us to transition from the legacy. So just think of it as AT&T buying communication service from a third-party provider. Number one, the price and availability of those services is diminishing. And you also have some concerns working with a third party for whether or not that information path can be compromised. So in many of our projects, we put up OPGW, optical ground wire, which is a fiber optic strand that goes in the static wire, which is the top wire on a transmission structure. That primary purpose for that is that you're trying to intercept lightning strikes, make sure your working infrastructure isn't compromised by lightning. But that sort of path meets the needs of it goes to the right places to get the information back and forth. And it also has some superior cyber attributes, I guess I would call them, in terms of just making sure that we have control of that cyber path.
Great, thanks, Ken. Other questions for Ken from task force members?
Madam Chair, I have a question. This is Tony.
Please, Tony.
Ken, we learned at our last meeting there's an opportunity or the possibility of some RICE units over in the eastern Upper Peninsula. And I thought they were based on that cable that's severed. If that cable is repaired or replaced, does that negate the RICE units that were proposed for the eastern UP?
Transmission and resources always work together. We would never say that more local resources are a bad thing, because there's always risk when you're trying to bring all of the energy from a farther distance. So the urgency in terms of having only a single circuit under the straits, that would be a situation that would be remediated by late summer of 22 or early fall of 22. But you would still want to think through a combined strategy in terms of what you were expecting for transmission, import capability, and what you were planning for local generation. The RICE units do have some really nice attributes in terms of being relatively efficient, more efficient than a classic simple cycle combustion turbine, but not probably as efficient as a combined cycle. So that's where the cycling goes. They're both using natural gas as their fuel. How efficiently you convert that to electrical energy is going to give you your spot in the market. So it's not a complete. The urgency probably would be not as strong after 2022, but I would not want to say that it's still not a reasonable piece of your total energy strategy.
Thank you. And it sounds like they would complement each other.
Yes, and that's actually when we go through the certificate of need process in Michigan, or I should say the generators do. They need to show that their proposal is the best, in the best interests of the citizens of the state of Michigan. And Kathy will correct me if I've got that maybe slightly wrong. But when you see some of the testimony, well, if I put this RICE unit here, I'll never need any more transmission. I just sort of go, well, okay, you have less urgency for the need for transmission, but they do complement one another. And in the long run, you do see the transmission grid evolving to the locations where the resources are, taking all of the signals back from the market in terms of the pricing of energy, what's the delivered cost of natural gas in the UP, and those sorts of things. So I always think of them as complementing one another, and not all of one or all of the other being the right answer.
Thank you.
Great. Thank you, Tony.
Can I ask this is Jen, I have a follow-up question. So that, to me, the site, you raised demand management at the beginning, and as we are bringing more smart features into the system up here, what do you see the role of demand management from your perspective?
It is very much a top of mind discussion. And actually, the energy world is full of acronyms. Well, it's not a 3-letter acronym, it's a 4-letter acronym. And so you wind up with demand response and then something called a demand response resource. The DRRs theoretically are taking that market signal and actually responding to it, actually modifying the amount of demand based on the price. We see much more of the demand response. That's a little bit more of a classic curtailable, interruptible, or time of use type rate that has been more well tested, and we know how customers react to that. The demand response resource has been elusive because we know pretty much what the price is for the next megawatt that we need. That's the way regulation has been done for hundreds of years, figuring out the next megawatt. The thought of relinquishing a megawatt and not using it, and what's my price for that? What's my price for not watching? And I'm a Wisconsin guy, so I'm a Packers fan. Turning off the Packer game on a Sunday. What's the price?
Oh, it hurts, Ken. It hurts.
Yeah, there's a lot of Packers fans up here. Yeah.
So the demand, long story short, the demand resources have been slower to kind of take root and kind of get traction. They're going to ultimately, my prediction is, if I was sitting here and I hold up my my Apple iPhone and know what my grandkids do with that very seamlessly, that may be where that finally does take traction, where your ability to make those choices on the fly or have an app that facilitates that for you, those things ultimately will come. The when is really the question, and what's the price? What is the benefit to the public in general, society, that I maybe relinquish my demand? And what does that turn out to be in a monetary sense for me if I'm the one that's foregoing that usage of the moment? Those are the pieces. As an engineer, I think of them as more political science and sociology questions, maybe economics questions as well. The technology probably is there. The way we behave as customers is catching up.
Yeah, great question, Jen. I think we'll have conversations too, more about how we're integrating different types of energy resources. Although I like Ken's philosophy that, transmission and generation go together, and I think these other types of resources do too. So I'm going to keep us moving because we're getting long here. But I think that that's a testament, Ken, to your presentation and to the engagement of these task force members. So with that, Ken, I'm going to thank you, and we're going to switch over to Kathy. I hope that you, given that you shared with us your contact information, I'm sure you won't mind if we have some additional questions if we follow up. We might have more that we want to talk with you about.
Okay.
Great. Well, thank you.
Very good.
Great presentation.
Bye-bye.
With that, Kathy, our frequent visitor, we really all very much enjoyed your presentation last time. So looking forward to an overview of MISO. So I'll hand it off to you.
Good. It's nice to be back, and it's nice to see everyone. Today, I'm going to talk to you just a little bit about MISO, and I'm going to try and share some slides here. That should be up. Let me know if you can see a slide there with the map. Okay. So we briefly touched in May on MISO and what they are. It's the Mid-Continent Independent System Operator. They're an independent nonprofit organization, and they operate in 15 U.S. states and 1 Canadian province. Just as Ken already mentioned, they work with Manitoba Hydro. This slide was taken from a presentation that MISO gave to the Michigan Public Service Commission about a year ago. So these slides are directly taken from a public presentation they made, and I just want to highlight the fact that there is a commission meeting on June 10th, which would be tomorrow, and MISO is going to be back to give a presentation at the commission meeting tomorrow about resource adequacy. They're probably going to primarily focus on the Lower Peninsula because they had some challenges this year, but if you're interested in another presentation on MISO, that will be a great place to catch up with them tomorrow. So they have 3 regions, basically MISO North, Central, and South, and Michigan is in the MISO Central region. It's a huge area that this system operator covers, and it includes lots of transmission owners like ATC that operate their own systems, and they do their own plans, and then MISO coordinates all of that through a stakeholder process. They have some key functions, and they believe their first key function is keep the lights on, safe and reliable operations of the electric grid. Ken already mentioned that they operate open energy markets, so they schedule an economic dispatch of generation to support reliability and efficiencies across the system, and they also do transmission planning. I'm hoping to talk a little bit more about MTEP, the MISO Transmission Expansion Plan, how that's developed, and the different kinds of projects that are in there. But before we talk about transmission planning, we'll touch on the generation dispatch. We touched on this last time in May, and Ken alluded to it as well. In the MISO market, there's all kinds of different generating units. We also talked last time about how some of the entities in the UP are utilities, some are co-ops, some are munis. Ken mentioned today that the city of Marquette operates independently, so that would mean that their generation is not necessarily part of this market dispatch, whereas those UMERC Rice units are in the market, just as Presque Isle was as well. So all of the generators and all of the resources, including that DRR, demand response, that Ken talked about as well, would have an offer. They would offer into the market at a price. MISO is going to stack all of those offers up, and they're going to take all of the cheapest offers until they reach that aggregate load, or if it's a day ahead, their aggregate load forecast for the upcoming day. Those are the units they're going to dispatch, and then the more expensive ones are not necessarily dispatched. And then it results in committed generators for the next day, the day ahead, and then they also do a similar process for the real-time market, which is, you know, on a minute-to-minute basis instead of on a day ahead, to make sure that the resources online match the load at any given time. Ken also mentioned that they have FERC-approved tariffs, ATC does. MISO has a FERC-approved tariff, and I've got the link here for you. We'll talk more about that later briefly. It's on their website. It's broken up into a bunch of different modules, and in order to have changes made to that MISO tariff, there's a stakeholder process that they go through that we'll touch on a little bit later as well. So all of the tariff and any changes to it have to be approved by FERC, and that includes both the market side of things for the generation dispatch, and there's also some things in there about transmission planning and transmission rates as well. So just as ATC has their 10-year plan and their outlook for where they want to create transmission projects to improve the system, there's a lot of different reasons that transmission projects might be proposed. And the first one that Ken mentioned earlier was reliability. So there's an organization called NERC, and I can't remember if I mentioned them last time or not, but it's the North American Electrical Reliability Council. And they have a set of reliability standards that outline how a transmission system should be modeled, how it should be evaluated, and what criteria would trigger additional transmission projects to be needed to meet those reliability requirements. They carry some stiff fines. It's $1 million a day for any non-compliance with those NERC standards, including the transmission planning standards. So ATC is subject to those standards. MISO is subject to those standards. There are even certain NERC standards that are applicable to generators, and basically everything that's on the bulk power system or the transmission grid is subject to some reliability standard. So if they say they need a project for reliability, typically they're proposing that project to be able to meet a certain NERC reliability transmission standard. Or sometimes companies like ATC will have their own planning standards that may be more conservative even than NERC's, because nobody wants to encounter any of those types of fines. They also will propose projects for economics. Ken talked about how there was the 30% off benefit, where you would put in a transmission project for reliability reasons possibly, but then there would be additional generation that could be accessed at lower prices, which would equate to like a 30% reduction in prices. Sometimes there are transmission projects that are proposed solely for economic benefits. And when they talk about the economic benefits, that's exactly what they're talking about. They're talking about the change in production costs in the market. So if there's a transmission project that's going to allow a whole bunch of more economic generation to be accessed, that would be considered an economic project, and there's a certain cost to benefit or benefit to cost threshold that would need to be met in order for that project to be deemed economic and pursued as a transmission project.
Hey, Kathy, I'm sorry, can I interrupt real quick?
Yeah.
Can you make your slides full screen? I think folks are really interested in seeing all of it and they just can't quite get to all the
Yeah,
content.
yeah.
Sorry to interrupt.
No, not at all. I actually don't give very many presentations either, so
Can't tell. You're a pro.
If you hit Shift F5 on your PowerPoint, you can go full
Shift
screen.
F5. Thank you very much. Let's see if that will work. There we go. You may be seeing the next slide as well.
Yeah, maybe it's wrong. Oh, well.
Yeah, just go escape back out.
Okay.
And then do what you were doing. Slideshow.
Okay.
Yep. And then from current slide. Try that. I bet that'll do us. Nope, never mind.
I must have a weird.
Same thing as Shift F5. That's what that does. Yep.
Yeah.
Okay, let me try something else. Let me
Things that
zoom for you.
you have the option to change it.
Yeah, if you have two screens, that's maybe what's happening.
Oh, double screens.
Right.
Okay.
Maybe it's full presentation on one screen and it's the preview on the other screen, and that's what you're showing.
I can, I did send these slides to Kimber, so maybe she can send them around afterwards if that would be helpful.
We will definitely share them, and for those who aren't on the task force, they will definitely be on our website as well.
Okay. So, all right, picking up where I left off, they analyze lots of different system scenarios when they come up with these transmission projects. Ken talked a little bit about a summer peak case, but they also look at other cases like a shoulder or a shoulder peak or minimum generation. They do look at all different system conditions to make sure that, especially for reliability, to make sure that they're always going to be able to deliver that energy. We'll talk a little bit about cost allocation mechanism, because just like when a utility builds a generator, when a transmission company builds a transmission line, those costs get allocated to retail customers through that FERC-approved tariff, of course. And different types of projects are allocated a little bit differently. So they coordinate their planning processes with neighbors, and then they also do some types of policy studies, whether it's for state or federal policy, just like that Eastern UP transmission study that I touched on briefly at the end last time. If we have time, we can go back to that policy study as well. This is a similar slide, and really what this is trying to show is that MISO's MTEP, which is their MISO transmission expansion plan, that gets developed every year, has a whole bunch of different inputs that come into it. There's a bottom-up planning process where the transmission owners are going to be proposing projects either for reliability or economics or for whatever reason. There's a top-down planning process where some things may be initiated from MISO. There's some projects related to interconnecting new generation. There's stakeholders that participate, including some of our MPSC staff. They do some policy assessments, they exchange information, and an out-of-cycle study, if you see that term, that just means that there's something that they need to get approved, typically on an expedited basis, such as if there was a new load, if there's a brand new customer, a new load that they need to interconnect to the system that requires additional transmission. They don't want to have to wait for the entire MTEP process to get that project approved, because the MTEP process takes more than a year. I think it might be around 18 months from when they start an MTEP cycle until the projects are finally approved by the MISO Board of Directors. And that approval occurs late every year. Okay, so really quick on cost allocation. Those transmission projects that Ken was saying that he might like to build, they would be categorized depending on what types of projects they were. And if it was a reliability project, I'll show you this baseline reliability project down here, the costs of those upgrades would be allocated to the local pricing zone. I thought I heard Ken say that all of the ATC footprint is the same pricing zone, so you can correct me if I didn't catch that right at the end of the presentation, Ken. If it's a market efficiency project, that basically means an economic project, one that would be built for economics. Some of that could be shared. That's what the postage stamp refers to if it was a 345 kV and above project. Multi-value projects are something that we had, I don't know, maybe like 7 or 8 years ago they started, and they were policy type projects. And those were shared across the footprint, postage stamp to load. We only had one of those in Michigan, and it was the thumb loop in the thumb in the Lower Peninsula for the wind resource zone that was there. Other projects is another one that you're going to see a lot in the most recent MTEP plans. If it's categorized as other, it's usually something like an asset replacement, like they have some old poles that need to be replaced, or other parts of the system that are just, they've aged and they need to be replaced, or they need more clearance or something like that. It culminates every year in a MISO transmission expansion plan, which is posted on their website. There's a link here on this slide to this MTEP, and this is just a screenshot of what they have on their website. But it's a big deal. 480 new projects for inclusion in Appendix A. And Appendix A is the list of projects that goes to the MISO board for approval. You know, lots of dollars here. Okay, the MISO tariff. All of the rates in the footprint are included in the MISO tariff. This is also a screenshot from their website. It's broken apart into a bunch of different modules. And one of the things I wanted to highlight on this page is that this responsible committee you'll see here. So for transmission service, the responsible committee is the Planning Advisory Committee. That's a stakeholder committee that will have meetings posted on their website. They'll have meeting materials posted. There'll be information to be able to join those meetings and listen if that's something that people are interested in doing. Resource adequacy, the resource adequacy subcommittee is another big one. Not all of the transmission details in the stakeholder committees are necessarily open to the public because of that critical energy infrastructure information that Ken mentioned. They do have some specific transmission planning meetings that require a non-disclosure agreement and other documentation to be able to participate in. But a lot of the MISO stakeholder committees are open, and the meeting information is actually posted on the calendar on their website. Here's a breakdown of those committees and how they bubble up to the MISO Board of Directors. As I mentioned, all of those transmission projects in MTEP, they go through an approval process where they would eventually be approved by the MISO Board of Directors. But they actually start down here under the Planning Advisory Committee in this planning subcommittee and an interconnection task force that reports up to the Planning Advisory Committee. And then it goes up to the Advisory Committee and the Board of Directors. Down here, this area is where there's a lot of stakeholder engagement, involvement, and in that transmission planning space, they do have some public meetings where they highlight the transmission projects that are proposed and what their reasons they're proposed for and their expected costs. And there's even discussion of how those costs might be allocated if they were approved as proposed. It also allows stakeholders to propose alternatives to those transmission projects as well. And those alternatives could be an alternative transmission project, or it could be a non-wires alternative, which could be a generation alternative. It could be a demand response alternative or something else. Now, I will say that MISO does not approve generation or demand response as part of their MTEP. They only approve transmission projects as part of their MTEP. But there's some discussions at times that happen there. Which brings me to the MISO stakeholders. Some of those work groups, like the advisory committee and possibly the planning advisory committee, they definitely the advisory committee. They are broken up into stakeholder segments, if you will, and each stakeholder segment is allowed a certain number of votes. For instance, I'm pretty sure the regulatory segment, which the MPSC would be a part of, is allowed something like 3 or 4 votes at the advisory committee level, and you can see that there's 17 of those state regulatory authorities that participate. So it's up to us as a group to come together and figure out our positions on different things before those representatives take the positions at those MISO stakeholder meetings. There is a group called the Organization of MISO States that Commissioner Scripps participates in that helps facilitate some of that involvement at the MISO stakeholder committee process, and then also at the FERC level, when the changes are proposed, we have another opportunity to weigh in those FERC proceedings. So last time I talked really briefly about the Eastern UP Transmission Expansion Study that was requested by Governor Snyder, May, and the MPSC. It was in 2017 that this request was made. I just wanted to touch on this again really quickly. There were 16 different possible transmission solutions that were proposed and tested by MISO. The first 4 of those different proposals looked at the connection to Sault Ste. Marie, putting in a new connection there because there isn't one that exists right now. And they also looked at some local Upper Peninsula upgrades in the area between the Sioux and the Mackinac Bridge. When they did those first 4 proposals, they found that there was a limited amount of transfer that could take place between the Sioux, Canada, and the Sioux, Michigan, without causing a lot of reliability problems, both on Ontario's system and on the ATC system in the UP. So those first 4, none of them were viable because of those reliability problems, and they limited the transfer. They started with a 400 megawatt level transfer they were studying, and the most that could be supported they found was about 125 megawatts. So they had to scale the transfer back to 125 megawatts. And then they also started looking in proposals 5 through 8 at some more substantial upgrades to the Eastern Upper Peninsula, as well as across the Sioux connection. And as they started progressing through those different scenarios or proposals that they came up with, the amount of infrastructure that was required was going up, and so the costs were going up. They actually then, for the next 8, the last 8, I guess, would be the proposals 9 through 16. They also looked at some connections that they included everything they did at the Sioux, and then they also included some incremental connections between the Upper Peninsula and the Lower Peninsula, as well as some significant upgrades going west in the UP. They looked at some on the southern end that Ken talked about, and they also looked at some on the northern end going across towards Marquette. And again, as those proposals were made, there was more infrastructure and it became more expensive. So the transmission and generation solutions that MISO looked at, because they did also look at generation in the Eastern UP and they looked at generation in the Lower Peninsula, the cost ranged from $92 million on the low end to $1.3 billion on the high end. And like this slide that I presented last time says, they found that the transmission projects that they studied were not economic, and that a generation solution in the Eastern UP would provide the same amount of benefit at a lower cost. And I would recommend that if the task force is interested in more details on this study, that a specific request be made to MISO so that they can present more fully on the study that they conducted and be able to answer questions that you might have. And with that, I can take any further questions. And I hope Ken's on the line so that I can give him all the hard questions.
Great. Well, thank you so much, Kathy. That was a wonderful overview. And I am interested, first of all, in task force members' questions, but then also task force members, I'll be interested to see if you want to hear more from MISO about that study. So I think Kathy raises a good point, which is that we could bring them in to present as well. Okay, task force members, questions for Kathy.
Madam Chair, this is Tony. I have a question for Kathy.
Please, Tony.
Kathy, did you say that in the conclusion of the study that Governor Snyder commissioned, that generation in the Eastern UP would be more economical than bringing it in? Is that what I captured out of that? I couldn't read it.
That is true. Based on those 16 scenarios that they studied, they found that the generator in the Eastern UP provided the same benefits as the transmission would have at a lower cost. But that is limited to the transmission solutions that they studied.
Okay. So, and there has not been any increase in generation in the Eastern UP, has there not?
No.
Thank you.
Mm-hmm.
Other questions for Kathy? Wow, Kathy, you might be off the hook.
Great.
Going once, task force members, going twice. Questions for Kathy? Wonderful. Well, thanks again, Kathy. Really appreciate it.
You bet.
All right. So with that, we are going to transition into the working session portion of our meeting today. So we wanted to add this to the agenda to give ourselves a chance as task force members to talk a bit about what we heard in the presentations, and then also thinking about what our next meetings will entail, what types of things the task force members are interested in hearing about. We've had a lot of sidebar discussions to kind of understand, and certainly, you know, we at Eagle, as well as our partners in the Public Service Commission, have ideas about what we think is important to put in front of the commission or the task force, but also wanted to hear from all of you. So those are the two agenda items on the table from my perspective. So with that, I'm going to open it up to task force members and invite your questions or comments. We're all pretty quiet today. I'm not sure what that means. This is not typically a quiet group, so it makes me a little suspicious.
I'll talk just to fill silence, I guess. I think it would be, so I think we've done some of the sort of global work in terms of the sort of broader context, but I think a lot of this probably gets pretty utility specific pretty quick from here. And the differences between utilities and how they operate and their cost structures and everything else. I think that was one of the takeaways that I heard from last time, and we've gotten some input from other task force members on questions that we're trying to respond to, but maybe moving to sort of getting the utilities teed up to talk about their service areas and their resource plans and the like might be sort of the natural next step from here. And I'm thinking not only about the 3 investor-owned utilities that we at the Commission regulate, but also there are a number of municipal-owned utilities that operate in the UP, and then a number of cooperative utilities, including Cloverland, Eldred Delta, the Ontonagon REA. So I think that might be the sort of the next place, is to start hearing from the utilities specifically. And I guess, you know, all of that is probably mostly on the electric side, but at some point we probably think about how we start addressing the gas side as well.
Yeah, that makes sense to me. I was looking at my notes from our last meeting, and we were hearing a lot of differentiation between the utilities, and so trying to get a better feel for what makes their different work, what gives it that distinction, I think will be really important. I like the transmission overlay today. So, I think we've done a good job of setting the table at this point. Yeah, I'd be interested for sure in going in that direction.
This is Jen.
Hi, Jen.
Hi. So when I tell people about the task force, there's pretty much only one question that comes up. Why are the rates so high? And so that sort of seems like the fundamental, and that, as Commissioner Scripps noted, is going to become specific to the utilities. But then there does seem to be something else going on. And I don't know that we want to become as educated in rate setting as we now are in transition, but maybe we'll have to, scary as that idea seems. But a couple of things that I can pull out of that very big question are, and I've sent these to Ms. Cole yesterday. I'm not sure who else I would need to send them to, but
yeah, it was actually your questions that I was responding to, Jen.
Okay, thank you. So things like, so what's happening in Wisconsin right across the border, and do they pay what we pay, and what's different? And the industrial rates in the Upper Peninsula tend to be very, 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 very low. Is that because of the interruptible service that they are willing to have? But that seems to also be skewing some of what goes on. And then the big third question I had was these changes in technology, which have also been alluded to today, and the need to move out of legacy systems into newer technologies, and what the financing options are. Those seem to be really critical in an overview, potentially, of financing options. And then the final one that popped into my head today is we do have community-supported electricity generation, mostly provided by solar, in some communities in the Upper Peninsula. And these big system questions where millions and millions of dollars are being spent assume that these large numbers are bringing benefits to lots and lots of people. But what if it's lots of small systems instead of one big system? And how could we have that conversation about many small systems versus one big system? And I'm done.
Thanks, Jen. I think those are important questions. I will say I am not sure that the task force will become rate making experts, but I do think that
I hope not.
We've got folks that can help us, kind of understand that. And we did, Kathy's presentation again last time, so not this meeting, but the meeting before, because of course, she is a rate making expert and works with rate making experts, did dive in a bit. And it was interesting already, even in the summaries, where you were starting to see things diverge from a why are the rates so high question. So that makes a lot of sense and seems like a place we should spend some time.
So this is Michael Larson. So maybe, and I don't know if it's too late to ask Ken a question, but thinking of Jen's discussion about whether or not that's one large centralized new generation of solar or wind versus many small ones, is the transmission that we currently have, is there one that's better for another under the current system that we have, or does the UP, the grid have to evolve somewhat, or the transmission have to evolve somewhat to be able to allow new generation to come online in many places versus a couple singular places? I don't know if that question exactly makes sense. But I know there's a lot of talk about renewables and siting. I know we've had public comment discussing on where to put it and so on and so forth. And but having an idea of that, is probably helpful.
So Michael, if I'm translating correctly, you're saying kind of that overlay between this future system and making sure that we're building in a way that is adaptable.
Yeah, I would say making sure that it's adaptable, and whether or not the system as it currently is, and as AT is projecting it, ATC is looking at it, over the next 10 years, is that able to take on, I know we've got UPCO that already is looking at a 125 megawatt system. Is the current system able to take on additional 100 megawatt, solar installations, or is it really more adaptable to, a group of smaller systems, or there are major changes that have to be put in place to take on some, additional larger solar installations or renewable installations for that?
Yeah, it's a good question. And Ken, I don't know if you're still on. I'd have to scroll quickly to see if you're there. So I'm just going to ask if you have anything you want to add on that point, or if that's just something we could touch base with you in the future.
Yeah, I hung around because I wanted to learn from Kathy.
Don't we all?
But yeah, the idea of many small distributed energy resources, another one of those acronyms, DERs, is something that is part of the modeling debate that's going on right now with MISO. MISO asking transmission planners like ATC to be more inquisitive or do more data gathering on what happens behind the meter. So BTMG, behind the meter generation, behind the meter resources, and distributed energy resources are very much hot topics right now. There's a little bit of pushback because sharing detailed technical information feels intrusive. MISO's point of view is if you're going to keep the lights on, you need to have no surprises. So you need to know what's going on behind the generation meter, as well as sort of that classic utility scale stuff. It would seem like you should be able to accommodate more of the smaller stuff spread out over larger areas with the existing transmission system. What you'd want to make sure is that when I mentioned those inverter control system stability, you want to make sure that all of those don't have some common link where they all would disconnect for a single reason, suddenly creating a large, it would make, if all of the small resources were masking behind the meter load, and suddenly that load became deliverable from the transmission system, you want to make sure the transmission system is capable of that. So it's very much something that is a current topic. Not sure exactly what the detailed answer is, but it seems like distributed across a broader area is more compatible with the system that we have today, just intuitively.
Madam Chair, if I could add to that, each year the organization of MISO states that Kathy referenced does a DER survey, essentially to help improve the MISO modeling. Those survey results have been collected by OMS. I think they're currently crunching the numbers, and we should have them at some point in the near future. So I'd be happy to share that when we have the final sort of report done. And then the other thing is, I think it's both a question of the transmission and distribution systems, and we may, if we have MISO in, may want to ask them. They do have a DER process, and sort of to investigate that. And then the other piece would be, as we're engaging with the utilities, the load serving entities, as we call them in the wonky utility world, we may want to also ask about integration on their distribution systems.
Oh, am I muted? Oh, no. Did you say that MISO does the DER survey annual, or I'm sorry, OMS does the DER survey annually?
Yeah, I believe their previous executive director launched this a couple of years ago, if I'm remembering right, Tanya. She's shaking her head.
We got the inside scoop on that then. Okay. Great. That's really helpful. Thanks, Ken. Thanks, Dan. Any other discussion points from task force members to help us understand what we heard and think forward?
This is Douglas.
Douglas.
Just a broad addition to our agenda, if you will. Upper Peninsula residents and businesses pay about half as much per year in dollar terms as they do for heating fuels as they do for electricity. And then they spend a little bit more than that for transportation fuels, a little bit more than the electricity spending. So as we think about energy in the Upper Peninsula and both affordability and security, and for that matter, certainly greenhouse gas emissions, the transportation energy is a very important part of that picture. Downstate, we have, it's still early, but fairly robust efforts underway by the major utilities with assistance from your energy office in Eagle to try to get some infrastructure in place. That effort is, and I think appropriately, but is lagging in the UP. And I think at some point we need to have some conversations about that.
Yeah, good addition.
This is David Camps. I agree with Douglas on, we need to consider EV charging stations and infrastructure in this mandate, this part of the mandate. And I don't know if any of you saw the comments on there, how many of them, but Rochelle Winkler had posted a pretty lengthy, good comment list on there that I think is very pertinent to what we're doing here by laying down a baseline, with using GIS mapping and what you have, and demographics and fuel source for generation and generation size of the utilities, all kinds of things she had in there, and distributed generation was to be mapped out also. But I think the silence you were hearing before, Director Clark, is that this is a massive topic here. It's a bit overwhelming right now, trying to get your head around how to organize it and pin some things down and where to go with it. But I think MISO, bringing in MISO might be a good idea, trying to figure out these securities and imbalances and stuff of the UP distribution network and get that more characterized. And then in Kathy's last presentation, there was a start on that with a list of power plants and investor-owned utilities, and she had who was doing hydro and their fuels and all that and the sizes. So I started characterizing those and seeing what kind of fuel baselines we have and stuff, how much coal, all that kind of stuff. And I think a place to start maybe is, I sort of agree with Rochelle Winkler, that maybe we get into the demographics of the cost of fuel, where it's generated, the load, where the load's located, and lay down that, get down a little deeper into the details and lay down a baseline on that level. Is the only way I know how to approach this right now.
Yeah, great. That's really helpful. Yeah, Rochelle Winkler's just been a great asset for building those foundation layers. So I totally agree. That's really helpful.
Thank you.
Yeah, thank you.
Hey, this is Tanya. Jump in with a couple of thoughts.
Sure.
Another piece that might be valuable is at least some basic overview of the important policy components for energy, that particularly because we didn't discuss electricity before, but just the fact that there are some requirements in our policy related to energy efficiency, demand response, and some of the components of the major energy legislation that has some bearing on how some of this may migrate over time. The siting and that piece clearly has had some implications on what's happening in the UP. So addressing that, probably not an entire session, but having some
touch points on that piece, particularly if we're going to look at community solar or those types of smaller projects that impact could have a bearing. And then the other piece is just the thought, and I think we've captured this, but to put it in my own words, of having at least some high level scenarios of what we think the not too distant future could look like that's different than today, and find a way to marry where we are, particularly rates being the concern.
Ooh, Tanya's frozen for me. Or am I frozen for you? Okay,
Nope.
You're all moving.
Yep, she's frozen.
Okay. We'll give her a second, and if we don't get her back, I took notes. I lost her at high level scenario of the not too distant future, what it would look like and how it could be integrated. So.
And honestly, I think we can get some of that from both the utility IRPs. The 3 in the UP have approved IRPs at the integrated resource plan, 10 to 15 year outlooks, as well as some of the announcements that their companies have made, that We Energies, which owns UMERC, Excel, which owns Northern States, both have sort of announced where they'd like to go. And some of that is also reflected in the MISO Futures process in terms of looking at what they expect the grid to look like sort of in the foreseeable future, and then what transmission will be needed to support that.
Okay. That's helpful, and we can follow up with Tanya in case there's anything else, but that makes a lot of sense. Is if we can figure out a way to lean on the expertise of the MPSC to do a presentation to set the foundation there.
Sorry, I got kicked off, but I'm back. Sounds like you wrapped it up, though. Thank you.
Dan played his best, Tanya Kozlowski. It was excellent.
It was a
Tanya
cool
Kozlowski
substitute.
playing Mike.
Tanya, we talked about using the expertise at the MPSC to do a presentation on the UP IRPs and utility announcements to try to piece together what that not too distant future could look like. So following your path of high level scenarios to give us an idea. I think, does that sound like where you were going?
Yes.
Perfect.
Perfect.
Okay, great. We will stay in touch to be advised by you to make sure we get the right kind of presentation. All right, this is really helpful. Anything else the task force members would like to make sure that they voice today so that we're all talking together?
This is Dave Camps again.
Hey, Dave.
I'd like, do we have to consider the fragmentation of the overall generation and utility mix up here? That we have a lot of I didn't even count them, but there was a few missing on the investor-owned utilities, and then the municipal and independent generators. There's a lot of them in the UP compared to the lower peninsula, and I'm sure that has cost implications. I don't know, do we need to consider that? Is there anything we can do as a task force to make recommendations on that?
Yeah, I think that's a great point, Dave. I don't have an immediate sense of how to minimize fragmentation, but I agree with your general perspective from the presentations that we've heard, and obviously from all of your experiences. Fragmentation is a big part of it. So I don't know if I've got my finger on kind of what the right recommendation would be, but hopefully if we focus and hear a bit more about that, something will come forward.
Good. Hopefully.
Hopefully. With all these smart heads. All right, anybody else have anything they'd like to lay on the table? If not, we'll turn to public comments. All right, well, thanks again to task force members. Good conversation here today. And I think you all know we've had really good participation virtually. So we've tried to keep our meeting structured so that we cover some policy chunks that are something that we can really bite off and have a good conversation about, but then also get to the public comment. So want to make sure we get a chance to do that every time. So before we go into public comment, I just want to remind folks to spend some time with our website, michigan.gov/UP Energy Task Force. There's lots of materials there, including previous recordings previous presentations. And you can also receive or leave us public comment there that gets distributed to all the task force members. So with that, I think I have 2 names with requests for public comment. So first on the list is Warren Bovin. So Warren, I'm going to ask you if you want to unmute, and while you're unmuting, I'm going to set my timer. We do like to keep public comment to 3 minutes. You're certainly willing to be repeat offenders. We have lots of folks that join us on a regular basis. And you're also, we'd love to receive things in writing as well. So all of it matters and all of it's received in the same way. So with that, Warren, are you able to hear me and unmute yourself?
Yes, Liesl, can you hear me? Can you hear me?
Sound great. The floor is yours, Warren.
Great. I'd like to read this, please, just to save time.
Sure.
I'm Warren Bovin from Gladstone, Michigan. I talked about solar farms last month in the May meeting, and I want to say that Orion Energy Group from Oakland, California, and UPCO want to build a solar farm here in Escondido Township in Michigan. Now, UPCO proposed that they will save customers $20 million for 25 years. Now, those numbers sound very impressive. However, if you break them down by month per customer, it doesn't seem like very much. So 25 years times 12 equals 300 months. 20 million divided by 300 months equals $67,000 per month. And UPCO's website says they have 52,000 customers. So 67,000 divided by 52,000 customers comes out to a savings of $1.28 per month per customer. Now, maybe I'm wrong, but that doesn't seem like very much money. $1.28 per month per customer. It might even be less because UPCO is a for-profit private company. I'm sure UPCO is going to make a lot of profits if they have the solar farm. So for me as one customer, that's $384 for the life of the plan of 25 years. So for me to receive all of that savings as a man of 72 years old, I will be age 97 to receive all of those savings. So that $20 million doesn't seem like as impressive as I thought for us customers. My point is that these companies propose $1 million plans, which are very misleading to the public. I want to thank you, Liesl, and the task force members. Keep up the fine work. Thank you.
Great. Thank you, Warren. Appreciate that. Next, we have, sorry, too many screens. Mike Booza. Mike, are you with us?
Yes, I am.
Great. Hi, Mike. Floor is yours.
Hi, my name is Mike Booth. I'm from the Sierra Club, and I want to initially thank everybody for allowing me to speak today. The Conservative Energy Forum has a proposal out that I would like to advocate for, where a lot of the oddball pieces of state land, and there's a lot of them that they have, maybe previous railroad passages, lands that they've taken back under taxes or a variety of other reasons, that they're proposing that we use to put solar on. Now, we have a lot of work to do. The latest COP25 for the United Nations says we got to reduce our greenhouse gases by 7.6% a year for the next 10 years. And that's a pretty steep climb. And I know this is only a small part I would of that solution for that, but I would strongly advocate for serious consideration of this, and this phone, but the more people that hear about this community, the more likely it will happen. Thank you very much.
Great, thank you, Mike. And And I think we have a third person, and I'm just going to say right now, before I invite that person to give comment, that if anyone else is interested in giving public comment, feel free to raise your hand, feel free to drop an email, or you can just speak up when Renee's done. So next I've got Renee Richer. So Renee, if you want to unmute yourself, and hopefully everything will work smoothly. Are you there?
Yes, I'm here. Can you hear me?
You sound great, Renee. Floor is yours.
This is Renee Richer, and I am from Delta County in Escanaba Township. At the last meeting, I had requested that attention be paid to distributed generation and community solar that would benefit local communities. Today, I'm asking that you would turn your attention towards community benefit agreements. So as UPCO puts out more requests for proposals, I would like to encourage the task force to see that community benefit agreements are a part of those proposals, and any company that's promoting or submitting a proposal have some form of community benefit agreement or propose how they will be working with the community. Thank you.
Great. Thanks, Renee. And those are all the names that I had received interested in giving public comment today. So with that, I'm going to look back at my agenda. I think we might have wrapped up just a few minutes early. So before I let everybody go, I'm going to make one more plug for the website, because there are a lot of previous materials available there, and you will also be able to see there as we make decisions about whether we meet in person in July, and then future dates. You'll be able to find that on our website, so backwards as well as forwards. I also want to say a huge thank you to the Eagle team. So Matt was on at the beginning to help us with technology, and then Jim stayed on towards the end to make sure we didn't have any problems. Kimber has just been huge in keeping me on track with all of this, as have James and Brandy. So continue to really appreciate the team there, making sure that we're doing our best to support all of you from a task force perspective. So we've been staying in a lot of regular touch, but I'm just going to continue to encourage you to reach out so that we can have a lot of back and forth. I think it's great when we have these conversations and people say, oh yeah, I sent so-and-so an email and I was thinking about this and dropped a line in between meetings. So I think it really helps for richer content to get us we'll meet our goals in the timeline that we have, but we'll do it more in a more fulfilled way when we're having all that back and forth. So thanks again to all of you and for all of your time. I know this is not a light lift. So with that, I give you 13 minutes back and I say thanks again. Really appreciate it.
Thank you.
Thank you.